Today I'm going to be playing and making DIY slime for the first time in my entire life. Slime is one of the most enjoyable toys to play among children and teenagers. The feeling of stretching the slime, bouncing it, and squishing it. It's very satisfying, and slime can act as a stress reliever too. No wonder many children enjoy playing with this toy. I know most of you have played with slime before in your life, but have you ever thought about what is the science behind the making of this beloved toy we loved playing in our childhood days? Therefore, in this experiment, we are going to look back at how mixing different volumes of ingredients would affect the physical properties of slime. Without further ado, I'm Kooperific, and let us explore the world of slime. The concept of making slime is simple. Slime consists of 4 ingredients: water, polyvinyl acetate glue, also known as PVA glue, borax, and baking soda. PVA glue contains long straight polymer chain-shaped molecules. The viscosity of PVA glue is as low as compared to slime because these chains can slide over each other very easily. To turn this glue into slime, we will need to make it more difficult for these chains to slide over each other. That's where slime activators or cross-linkers like borax comes in. Borax contains borate ions, which forms connections called hydrogen bond crosslinks between the polymer chains. This begs another question. How do we get this borax from? It is formed from mixing contact lens solution and baking soda. Contact lens solution contains a mixture of boric acid and sodium tetraborate decahydrate. However, we can't just use contact lens solution alone because the pH of the solution also plays a crucial role in making the slime. An acidic medium where boric acid remains would break the hydrogen bond crosslinks between the polymer chains, causing the slime to behave more like a liquid, whereas an alkaline medium like baking soda would reform these crosslinks, causing the slime to behave more like a solid. That is why we would need to add baking soda, which is sodium hydrogen carbonate, to the mixture in order to remove some of the boric acid to make the mixture less acidic and more alkaline. This can be done through a reaction between boric acid and sodium hydrogen carbonate to form salt, carbon dioxide, and water. Okay, time to make our first slime. The materials we will be using for this experiment are an electronic balance, dropper, teaspoon, 30cm ruler, 50cm cube measuring cylinder, plastic food container, distilled water, Elmer's glue, Elmer's magical solution, and baking soda, also known as sodium hydrogen carbonate. Ignore the thermometer and food coloring cause I didn't use them. We're gonna use a measuring cylinder to measure half cup of water, half cup of glue, give it a good mix. Use the fancy dancy electronic balance to measure specifically 1 teaspoon of baking soda. Using the measuring cylinder, measure 1 tablespoon of magical solution, and BAM! Okay, for the moment of truth. Ugh, yeah. Ugh, oh my gosh. Yeah. Very icky and very soggy. I mean, I literally followed Science Buddy's slime procedure. How could it possibly go wrong? I mean, maybe I added too much water. Haha, Hoenn region. Okay, look at this. Although water helps the polymer molecules slide past each other so that the slime can flow, adding too much water would make polymer molecules slide past each other way too easily and it'll become soggy and liquish. Ugh. Okay, you know what? Let's ignore the Science Buddy instructions completely and let's just follow what is written on the Elmer's glue instruction manual. We are not going to add any water or baking soda at all. I ran out of glue, so I bought a new one and it was purple in color. So also I used newspaper because, well, so that the kitchen counter wouldn't get messy. And you know, I kind of tasted some slime in my mouth from yesterday's dinner, you know. Just kidding, I just wanted the cleaning process to be less tedious. But anyway, 70 cm cube of glue, 25 cm cube of magical solution, and tada! The best slime I have ever made! It's stretchy, more solidified, squishy, and acts more like a slime should, breaking easily with little stretchy surface, stretching when pulling apart very slowly, cold, and most importantly, it was bubbly. My only complaint though was that even though it was a lot less sticky than the second slime I have made, but it sometimes sticks to my hand, so it can be sometimes annoying at times. Okay, the circle diameters measured are also generally longer, so that's a plus. I have a lot of fun playing with slime, given this was my virgin experience. It may feel a little bit weird playing with slime for the first time. It was certainly a sticky situation, but with more practices and attempts, I have finally gotten used to making and playing with slime. What I learned from this experiment is that moderation is key. Thanks for watching. If you enjoyed the video, go smash that like button and subscribe to my channel. Man, I really wondered what happens if I were to play with slime when I was young.